Right, now that we've got our showing our walls and we've actually added the other 3 walls in, we've got to update our bounce code so that it will bounce on all 3 walls, not just the bottom wall. Okay, so to do that again, we're going to go back into our ball world, and we want specifically our ball. Okay, so we've got here where we make an attempt to move the X and Y. We say this is where we think it's going to be, and then here inside this for each, we look to see if it bounces against any of the walls. Okay, and then in this, if we detect as a bounce, we might change that new X and Y position, and then right at the end, whatever the new X and Y position, we make that the actual X and Y position. Okay, we've already got one, and this is where we are looking at a horizontal wall, and then we're looking to see if it's in the wall's range, and then we're looking to see that we've bounced. Specifically, so I've put here we've bounced, and we say we've bounced down, okay? Because as well as bouncing down, we could have bounced up, okay? Now, there's another thing I want to do here. Okay, so we've got our we're comparing to see if it's in the wall range by looking at the X pos and the Y pos. Now, we could have a problem here, okay, that the X pos itself may not be in the wall's range, but as it moves downwards, maybe in a diagonal manner, it could come in to the wall's range, okay? So what we need to do is not just think about the X pos, but think about the new X pos and the new Y pos, okay? So what I'm going to do is where I've got here my new X and new Y pos, I'm going to add them as private variables, okay? So private double new X pos, comma, new Y pos. Okay, and then here, get rid of the double declaration X. All that will do is that will effectively mask this idea that I've got a field level variable. Now, the reason for that is I'm also then going to set up a couple of properties. Now remember, we can have properties that aren't actually underlying data, but they do a bit of calculation. Okay, double, and I'm going to call this one looking at Y pos here. So this is going to be the max Y okay, and what I'm going to do with the max Y is going to say if new Y pos is greater than Y pos. No, I'm wondering why I'm getting red underlines here. It's because I haven't done the get. I'm making a mess of this to begin with. So if new Y pos is greater than Y pos, I'm looking for max at Y, then return new Y pos. Else return Y pos. Okay, and that's going to give you whatever the maximum Y position is. Okay, and I'm just going to repeat that 4 times for min max of both X and Y. Okay, so let's have a min Y, and then that's going to return Y pos, and that's going to return new Y pos. So that means if new Y pos is bigger than that, then we return Y pos because that's definitely the min. Okay, and let's go with max X, and I'll just replace my Y's with an X. Okay, now this becomes important because as we get our 4 walls in, this is going to reduce the loss of balls at the corner. it's likely you'll still have balls that might escape to the corner, especially when you've got like hundreds of balls on screen, but this will reduce it by quite a lot. So change them to X's, change that to an X, change that to new X balls. Okay, now I'm going to shrink these down because it's quite a lot of code there for something that is relatively minor. Okay, so now here where I'm looking to see if it's in the wall's range. So if I'm saying that the X position, if X pos is greater than the X position, okay, so what I want to say here is max X. Get rid of the pos. And yeah, max X, that's right. Max X is greater than wall X pos, and min X is less than the wall X pos plus length. Okay, so that's the minimum point that it could be. That's the maximum point it could possibly be. I'm going to come back to this. I might have got this logic slightly wrong. We will have a look at it again in a minute, but all we've done there is made that a little bit more accurate. We've not actually started putting any more bounces. So let's get the other bounces in. So here, I'm going to go else if, and this is where I'm going to look for my bounce at the top. Okay, so I'm going to take that as my kind of starting point and have a think about it. So here I'm saying the Y pos is less than the wall dot Y pos. So I'm saying if the Y pos is greater than the wall Y pos, and the new Y pos is less than. Okay, so that means it's gone up above. Now I'm also going to have a quick think about the diameter as well. How will the diameter affect this? So the wall Y pos is, so I actually say the wall Y pos plus diameter. Okay, because otherwise it's in a position where it's partly through the wall, and later on we're going to add a squash to it, which will show that whilst it's partially in the wall, it's not bouncing, but it's kind of squished down. Okay, so that means it's bounced up. Okay, so we've bounced on the wall that's above us. Okay, so again, what we want to do is we want to find out what the change is going to be. Okay, so if you're in class, you'll have seen me draw this on the board. Okay, but effectively what we're doing is we are looking for the difference between them. Now with this one it's actually a little bit easier. Okay, so what we want to do is find out how far below the wall it is. We need to find the difference between the wall and the new Y position, and then we want to subtract the diameter from that and then add it to the wall, and that will give us a position where it is above. Because remember, with the Y position, 0 is up, so the origin is top left. Okay, so the bounce difference is just quite literally the other way around. Okay, so we're going to take the wall Y position and subtract the new Y position, and that gives the bounce difference. Okay, and then the new Y position is equal to the wall Y position plus the bounce difference minus that. Okay, now hopefully if we run that, we will see that in action. that did look like it bounced, and it's done some weird bouncing stuff there. So it's definitely bouncing, but we have some anomalous code as well that's caused that kind of jaggedy bit, and it's now fired off the top. Okay, but we'll look at them a little bit later. We've got the basics of our bounce code. We can look at some buggy situations a little bit later. Okay, so now we've got the else must be vertical, and so now again what I'm going to do is I'm going to take all of that code as a starting point. Okay, now we're looking within the wall's range, except this time it's always the y. So if max y is greater than wall's y position and min y is less than the wall's y position plus the wall length, it's in the range. Okay, and then here we're going to start with a bounce to the right. Okay, so that means the y pos, actually make that to the left because then the inequality is the right way around. So that would mean the x pos is going to start off less than the wall x pos, and then the new x pos is going to end up greater than the wall's x pos. Okay, so in that situation, and again, if you're in class, you'd see me drawing it on the board. We are going to look at the difference, and it's very similar to the bouncing down here. So we're going to find the difference between them, okay? And we are going to subtract them and then add in and subtract again the diameter. So it's basically, it is the same as what we have, except we change our x from y's, or y's for x's. Oh, wrong one. And then the new x pos is going to be the wall's x pos minus the bounce diff minus the diameter. And then we also just want to invert the x velocity this time and not the y velocity. And then here we're going to do our bounce to the right. Okay, so that means the x pos is plus the diameter is going to be greater than the wall y pos. That diameter I think feels wrong, so I mean, let's think about this one here. Y pos plus the diameter is greater than the wall, and then the new y pos is less than the wall. Now this plus diameter, I think that's what the problem is. The plus diameter is on the wrong side. Oh, wrong bit. I've put it on the wrong side here again. It's the new y pos plus diameter. So x pos plus diameter, x pos being greater than the wall's y position means it's starting to the right of the wall, and the x pos plus diameter less than the wall y position means it has cleared the wall to the left. So there is now air between the right hand side of the ball and the wall. That means we bounce to the right, and again we should just be a case of swapping y's for x's. So the bounce difference is going to be the wall minus the new pos. No, I think that's wrong. I think we got that wrong over there as well for the bouncing up. So the wall x pos is going to be, the bounce difference is going to be equal to the wall x pos minus the new x pos plus the diameter. Okay, and that will give us the gap not from the left hand side of the ball but from the right hand side of the ball. Okay, and I think that's going to be the same here. So the wall y pos minus the new y pos, yeah, plus the diameter. And I don't think we need that there. So Yeah, no, we don't need that there. It's just the bounce difference. I did think something felt a little bit wrong then. We could see the way it was definitely bouncing, but there was something a little bit off in the bouncing. And I think that's the problem that we had there. So let's continue changing our X's for Y's for X, should I say? So let's get rid of this diameter here. And then last thing, change these Y's for X's. Now, if this all works in one go, I mean, it hasn't already worked in one go, I will be amazed. And I'll be amazed when I do it in class, it'll all work in one go. But, you know, we give it a bash. Now, the other thing I want to do, actually, no, I'll do that in the next video. Let's just run this and see if we've got at least a working one. I mean, it's likely to be buggy. We can deal with the bugs later, but as long as we can just see definite bouncing left, bouncing right. Well, that definitely didn't work. See if you've got bouncing. Okay, so the right hand side bounce is working, but the left hand side clearly is not. Okay, which is absolutely fine because that will give me a chance to do a video where I will look at the bouncing. But we can see that blue ball there has bounced back off the right hand side, but the left hand side hasn't worked, and also we can see the top is still doing some very strange things as well. As I say, this never works the first time.